Welcome to the fourth video in our series on Science 9B4 Chemical Nomenclature. This time we are looking at combining chemicals. Students will identify examples of combining ratios or number of atoms per molecule found in some common materials and use information on ion charges to predict combining ratios in ionic compounds of two elements. Introduction to combining chemicals. Understanding how atoms combine to form molecules and compounds is a fundamental concept in chemistry. The way atoms join together is not random. It follows specific rules based on their properties, such as their charges and the number of electrons they have. In this section and video, we will explore how to identify combining ratios, the number of atoms per molecule, in some common materials, and how to use information about ion charges to predict combining ratios in ionic compounds made from two elements. Combining ratios in common materials. Let's start by looking at some common materials and their chemical formulas. A chemical formula tells us the types and numbers of atoms in a molecule. For example, the formula for water is H2O. This means that each molecule of water contains two hydrogen atoms and one oxygen atom. The combining ratio here is 2:1, hydrogen to oxygen. Another example is carbon monoxide, which has the formula CO. This tells us that each molecule contains one carbon atom and one oxygen atom. The combining ratio is 1:1. Compare this to carbon dioxide, which has the formula CO2. In carbon dioxide, each molecule contains one carbon atom and two oxygen atoms, so the combining ratio is 1:2. These ratios are important because they show us how atoms are arranged in molecules. The chemical formula is like a recipe, telling us exactly how many of each type of atom are needed to make one molecule of a substance. Predicting combining ratios in ionic compounds. Now let's look at ionic compounds. Ionic compounds are formed when atoms transfer electrons to each other, creating ions. Ions are atoms or groups of atoms that have a positive or negative charge. The combining ratio in ionic compounds depends on the charges of the ions involved. For example, sodium chloride or table salt is made from sodium ions, Na+, and chloride ions, Cl-. The superscript plus on the sodium, that Na+, that plus tells us there is one positive charge. It has given up one electron, where we count the charges just as the number of electrons or protons, because they have equal but opposite charges. Chloride ions are Cl- because they prefer to gain one extra electron. They now have one more electron than proton, so their balance is 1 to the negative. Sodium has a charge of +1. Chloride has a charge of -1. We just described how to read that from our superscripts. Because their charges are equal and opposite, they combine in a 1:1 ratio. The formula NaCl tells us that each unit of sodium chloride contains one sodium ion and one chloride ion. Let's look at magnesium chloride, MgCl2. That 2 makes a difference. Magnesium forms ions with a charge of +2. It's Mg2+, while chloride ions have a charge of -1. That's Cl-. To balance the charges, we need 2 chloride ions for every magnesium ion, because 2 times -1 is -2, which balances the +2 charge from magnesium. Generally speaking, we're going to be taking our two charges and looking for the least common multiple of both. The formula MgCl2 shows that combining ratio, 1 magnesium ion to 2 chloride ions. Using ion charges to predict the combining ratios. To predict the combining ratio in an ionic compound, we follow these steps. Step 1. Identify the charges of the ions. So look them up on the periodic table. You can recall them. I don't expect my students to memorize anything that's on that periodic table of the elements, but some teachers do. Some students will just accidentally memorize it because they use them often enough. But you look up or recall the common charges for each element when it forms an ion. You balance the total positive and negative charges. The total charge in the compound must be 0. The positive and negative charges must cancel each other out. And then you write the formula. Use subscripts to show how many of each ion are needed to balance the charges. So let's try this with iron and oxygen. Iron can form ions with different charges, either +2 or +3. Oxygen usually forms ions with a charge of -2. If iron is +2 and oxygen is -2, we need one iron and one oxygen ion to balance each other out. That formula would be FeO, and the combining ratio is 1:1. But if iron is in the +3 state, Fe3+, we need to balance those charges with oxygen's -2 charge. Least common multiple of 2 and 3 is 6. So we're finding the smallest number that will make the total charge 0. That's our least common multiple. For 2 iron ions, 2 times 3 is 6. For the 3 oxygen ions, 3 times -2 is -6. So the formula is Fe2O3, and the combining ratio is 2:3, iron to oxygen. We get iron up to +6 by bringing in 2 of them. We get oxygen to -6 by bringing in 3. Why combining ratios matter? Combining ratios are important because they determine the properties of the compound. If the ratio changes, the compound changes. For example, CO, or carbon monoxide, is a poisonous gas, while CO2, carbon dioxide, is a gas we exhale and plants use for photosynthesis. The difference is just one oxygen atom per molecule, but it makes a huge difference in their properties. In ionic compounds, the combining ratio ensures that the compound is electrically neutral. If the charges are not balanced, the compound cannot exist in a stable form. If all the molecules have a +1 charge, they will repel each other and tear the material apart. So in conclusion, understanding combining ratios and how to use ion charges to predict them is a key skill in chemistry. By looking at chemical formulas, we can see how many atoms of each element are present in a molecule. By knowing the charges of ions, we can predict how they will combine to form stable compounds. This knowledge helps us understand the structure and properties of materials all around us, from the water we drink to the salt we use in our food. Check for understanding. What is the combining ratio of hydrogen to oxygen in a water molecule? Is it 1:1, 1:2, 2:1, or 2:2? Pause now if you need more time. It is 2:1 H2O. That O does not have a subscript, so the 1 is implied. In carbon dioxide, what is the ratio of carbon atoms to oxygen atoms? 1:1, 1:2, 2:1, or 2:2? Pause now if you need more time. 1 carbon for every 2 oxygens. Sodium has a charge of +1 and chlorine has a charge of -1. What is the formula for the compound they form? NaCl, NaCl2, Na2Cl, or Na2Cl2? Pause now if you need more time. It is the first one, NaCl. Na2Cl2 would also balance, but for ionic compounds, we take the lowest ratios or the lowest set of subscripts that will satisfy the conditions and balance the charges. Magnesium has a charge of +2 and oxygen has a charge of -2. What is the formula for the compound they form? MgO, MgO2, Mg2O, Mg2O2. Pause now if you need more time. The answer is MgO. They balance each other 1 to 1. Again, the Mg2O2 is a little too large. We use the minimum ratio that works for ionic compounds. Aluminum has a charge of +3 and sulfur has a charge of -2. What is the formula for the compound they form? ALS, ALS2, Al2S3, Al3S2. Pause now if you need more time. For this, the least common multiple of 3 and 2 is 6. We want to get both to a multiple of 6. Aluminum to +6, sulfur to -6. That means we'll need 2 aluminum and 3 sulfur, making it Al2S3. If you have any questions or any other feedback, I'd be happy to respond. Please leave it in the comments and I will try to respond to those questions and feedback in a timely fashion.